5 people are about to receive a total of 5 prizes. The names of the people are Beth, Clyde, Jerry, Timmy, and Erica. The 5 prizes are a violin, a skateboard, a fishing rod, a toaster, and a pogo stick. First, one of them will be randomly chosen to take a prize. Then, one of the remaining 4 people will be randomly chosen to pick one of the remaining 4 prizes. After that, one of the remaining 3 people will be randomly selected to claim one of the last 3 prizes. Next, one of the last 2 people will be randomly selected to take one of the last 2 prizes. Finally, the last person will take whichever prize is left. Clyde wants the pogo stick the most out of all 5 prizes. When it is Clyde's turn to select a prize, Clyde will choose the pogo stick if it hasn't been taken yet. Everyone else has no preference in which prize they get. Whenever it is either of their turns to select a prize, the person whose turn it is will choose a prize at random. What is the probability of Clyde getting the pogo stick? The overall probability of Clyde getting the pogo stick should be equal to the probability of Clyde getting the pogo stick if he gets to choose first, multiplied by the probability of Clyde getting to be the one who chooses their prize first, plus the probability of Clyde getting the pogo stick if he gets to choose second, multiplied by the probability of Clyde getting to be the one who chooses their prize second, plus the probability of Clyde getting the pogo stick if he gets to choose third, multiplied by the probability of Clyde getting to be the one who chooses their prize third, plus the probability of Clyde getting the pogo stick if he gets to choose fourth, multiplied by the probability of Clyde getting to be the one who chooses their prize fourth, plus the probability of Clyde getting the pogo stick if he gets to choose fifth, multiplied by the probability of Clyde getting to be the one who chooses their prize fifth. The probability of going first, second, third, fourth, or fifth is 1 in 5 each. Since all numbers that are being summed up are being multiplied by 1/5, we can make the formula neater by factoring out the 1/5. Or we can instead divide the entire sum by 5. If Clyde gets to choose his prize first, it is guaranteed he will get the pogo stick. If Clyde is the one to choose their prize last, there's a 1 in 5 chance of the pogo stick still being there. If Clyde goes second, there's a 20% chance of the first person taking the pogo stick, leaving a 4 in 5 probability of the pogo stick still being up for grabs when it's Clyde's turn. If Clyde gets to go third, there's a 2 in 5 probability of the first or second person taking the pogo stick, leaving a 3 in 5 probability of the pogo stick still being unclaimed when it's Clyde's turn. If Clyde is going to be the fourth person to select their prize, there is a 3 in 5 probability of one of the first 3 people taking the pogo stick, leaving a 2 in 5 probability of the pogo stick still being unclaimed when it's Clyde's turn. With all the variables deciphered, we can solve the equation. But first, we can make things easier by replacing the 1 in the beginning of the fraction with a 5 over 5. Since all fractions in the numerator that are being summed up have the same denominator, we can make the numerator a single fraction. Five plus 4 plus 3 plus 2 plus 1 equals 15. 15 divided by 5 equals 3. We now have a solution, 3 in 5. I also thought of a formula that can be used to decipher the probability of Clyde getting the pogo stick, even if the number of people and prizes is a variable. Let P equal the number of prizes and the number of people. Each spot in the turn order has a 1 in P chance of being Clyde's spot. If Clyde ends up being the one who gets to choose their prize first, the probability of him getting the pogo stick is P and P. If Clyde is rather the second person who gets to choose their prize, the probability of him getting the pogo stick is P minus 1 in P. If Clyde instead gets to go third, the probability of him getting the pogo stick is P minus 2 in P, and so on, with 1 in P being the probability of Clyde getting the pogo stick if he gets to choose last. Since all numbers that are being summed up are being multiplied by 1 over P, we can make the formula neater by factoring out the 1 over P. Furthermore, all numbers that are being summed up are fractions with P as the denominator. Because of that, 1 over P can be factored out a second time. What we have can be rewritten as the sum of all integers between 1 and P over P squared. Another way of writing the sum of all integers between 1 and P is 1/2 times P times 1 more than P. The overall fraction can be simplified by multiplying the numerator and denominator each by 2 and dividing the numerator and denominator each by P. That is the overall probability for any value of P. P plus 1 in 2P.